Hi, welcome back to Object-Oriented Comprehensive Guide in Python. Now we are at section number 5, Use of Object-Oriented, When to Use, and the Feasibility Vision of it. In this section, we're going to be discussing a number of outlines. First, we'll be looking at object and function-based design. Next, we'll be looking also to understand the concept of a property in object-oriented overall and Python in particular. Then we'll be looking at the use of a property as a decorators and what kind of functionality we can utilize and benefit from. Finally, of course, we're going to close everything and wrap it up with a case study. Let's go ahead and start with the first outline. So in this outline, we're going to be talking about object and function-based design. To get you to understand, first, let me remind you, the idea of object-oriented we have learned from the very beginning that we have got this kind of object we define, and this object concealed within number of attributes or characteristic and number of methods or actions that we need to take within what's so-called a class. Now from this class we can instantiate those objects and we can deal with them. So that was the main perspective of object-oriented. And then we have tried so far to show you some of those functionalities and features we can utilize given the fact that we rely on object-oriented. However, in this particular section, I wanted to show you that there are some tasks can also be done using standard functions. But the question will be then left to answer, which method shall I go for? Or which design shall I be using? Is the function design or an object-oriented? Let me show you that with a real example. Let us assume if we want to design a program to model a polygon in two-dimensional space. We might start with each polygon represented as a list of points, and the points would be modeled as a tuples, like kind of X and Y, so to speak, to describe where the point is located. And this is all data. So those points represent the data. Now we store in a set of nested data structure, especially like a list or tuple. Like in this case, let me show you. Here we have this vertex of X and Y, another vertex, and so on. Now, if we want to calculate the distance around the perimeter of the polygon, we simply need to sum the distances between the 2 points. And to do that, we also need a function to calculate the distance. This will represent behavior. Now here in this particular example, I wrote the exact things I was talking about using a function-based design. So what is function-based design? Here there are two functions. One function represents a distance, one function represents a perimeter of the polygon that we want to actually calculate. So this function expects to receive a kind of argument called a polygon. It doesn't matter, it doesn't really know what's a polygon until we decide. So here I'm setting a variable called parameters to 0, and then I'm defining a new variable called point. And in particular, this point is saying that I'm going to take the argument of polygon and we'll add to it the polygon sub 0. So it seems to be that the polygon here, if I want to make some doc string, it means a polygon itself, it is a list. That's why I can add to the first index of that list. So these are important when you want to utilize a doc string that we discussed before. Anyway, this is just an illustration. Now, point in this case, if I would have to pass to it, it will be whatever was inside the polygon, and it will add one more, which is the first index of that list. Then I'm creating control flow of for loop in the range of that polygon. So how many items within that list I will be looping depends on that. Then here I am using this parameter which I set to 0. This parameter, as you can see, plus equal, so every time we'll be adding to that. So what he's doing is taking access to another function called distance, and this distance function which we wrote up there, which actually expect to receive P1 and P2. So what is P1 and P2? That's what I have passed here from the point that I have desired from the polygon. So until now, the things are still not so clear until I can write a doc string or the programmer himself understand what he's talking about. But what I know, point here represent the list, and I'm joking that index and the next index of it. That's why I'm looping it the first time. And then I'm returning this parameter anyway. So out of these two functions, what I have come to do, I define this variable called square, which is a list. And inside the list, what we have number of tuples. So I have tuple 1, 2, 3, and 4. Now, what is going to happen? I want to print the parameters here, passing that square or that list of tuples as we done in here. So once I do so, what is going to happen? This square will be passed. Now it's the tuple, and then it will be stripped down by taking whatever is the list, and it will add to it one by one. So I'm adding just extra one in case I'm passing that left empty. And the distance will be calculated by taking every point. And basically, the distance is as simple as calculating the Euclidean distance from math modules that I imported in the top of this module. So here I'm taking the square root of the first point of 0 minus the second point, of the x, so x1 minus x2, and then squared plus. So this is the standard math we learned before. And then I'm returning that, and that's what has happened. And this is one distance, and I will keep at these distance altogether. Now, if I would have to run this, I will get the desirable result, of course. So where is object-oriented? So I have written exactly what you see here using an object-oriented. Let me, in fact, try to double that down to show you both of them next to each other. Now, the same exact function here, I'm using now object-oriented design. The first question I'm going to ask myself, what is the actual data here? What's the actual actions or attribute? What are the objects, etc., as we discussed in analysis, design, etc. It is obvious from the design that in every polygon, I can use a point that have the x and the y, and I can take this distance to be encapsulated as the action. So now I have an object called point. And this particular point object can be used by the polygon because the polygon have number of those points. Now, from token perspective, I have just created this object-oriented idea. So what happens here, I can create a class called polygon, and I can use the dunder within it. And then I'm creating this empty list. Of course, I can even customize this list if I want to add some action to it. We discussed that before. And then I'm using this internal sub-function called add point. And here's the beauty of using object-oriented. Now, every polygon that I'm instantiating object from, I can access to add point. And basically, an add point, he's expecting me to pass an argument. And what's inside that argument, it's just gonna go and add to the vertex list every point that I am passing here. So basically, I take the point and I'm just appending that to the self.vertex. There is one more function called the parameter. And this parameter is going to do the magic that we were talking about here by calculating actually or summing up the distances. So same, I'm just setting local parameters here or variable called parameters to 0. And then I'm taking the self vertex. Now it is available and added here every point I'm adding. And I'm adding that to this list particular. And then I'm doing the loop idea, as you can see here, which we did exactly in the function design. Say I'm looping inside the self list of vertex, which is this guy here. It depends on its length. And then I am taking the points of I. Now I can make control if the point match certain characteristic, is it a tuple or not, etc. Even with writing the doc string or without, I have control over that. That's why it's unlike the function design. It was a little bit challenging to follow if this code has been handed over to somebody. But with the object-oriented, it's very clear that I can do so clean and tidy. So I'm taking the point of I in dot distance, and distance, of course, it can be reached out from the point here, plus I plus 1. Though the length of writing the code multiple line compared to this have as much, but this is not the way we actually think from writing code perspective, which one is shorter than the other. The point is that which one is readable, maintainable, easy to follow and access. Let me, since both of them are inside the same file, I'm going to terminate this function. I will be instantiating polygon, and then I'm adding point. As you can see here, I am inheriting directly from the point. So every point here, it is an object of the point class. You can see here clearly. That's why I would enjoy reaching out to the distance from the first. So I just add the same exact points that were here. And then, of course, after I finish, I took that object that I instantiate and I reach out to the perimeter and make the printing as expected. So if I would have to run this, I should be able exactly to get the same result that I just get it before, which is 4. So nothing changed, but the design has changed. And why this is very powerful, because I can make so many changes. Let's imagine for some reason I don't want to instantiate this way, but the fact that I could create here directly a square this point and I pass it directly in the instantiation of the polygon. So in that polygon here, I would just change that under here. Let's say, for example, I would just create here like points, and maybe let's set it to none, just in case if it's passed or not. And he just a nice change. Let's say here, I'm going to check points. It will be equal to points. I mean, the one is just passed if the points is in there. So if in other words, this line say if the points are assigned, then the points will be equal to these points. Else, I have to put else here. Of course, it's going to be just an empty list. So basically, I'm just passing a list. And we can keep, of course, the self.vertex as they are. Nothing I'm going to change here. And I'm going to just close this. And see here, I can have this self.vertex exactly as this. Now, here's the point. I'm going to make a simple loop. Let's say for point in the points. And I want to say if is instance of. Now I'm going to check if every point has been passed to me. It's actually of type tuple. So just to make sure that we are matching the standard. In this case, then the point itself will be equal. Now I am creating an instance from the object class. And this case, of course, I can use a very nice trick. Instead of using that point X alone, and then I have to use Y alone, I can use this star point that will unpack actually each point had been passed. I will show you that what would look like. And after I finish, simply what I could do is just go to self.vertex, and then I can append that particular point. Great. And actually nothing else will be changing afterwards. So the only change will happen here. I would, instead of using that particular style, I would just simply take the exact same thing what happens here, this particular line. I could actually pass it to the polygon as I am making my design. So try to run that and see what the result would look like. Here we go. We are getting the exact same result. So here what happened, I make the control within the dunder. If I don't want to do so, I still can add other point as well. So I could have add this, and in addition, I can also add one more point along the line. So I have access in both. So you can see the powerful, accessible, and maintainable style of doing all that kind of work. So we have these two tasks, comparing using a function-based design or object-oriented design. And don't be misled that the number of lines doesn't really matter, because this is very readable. Without any doc string, if I am following the line, I would understand what's going on. But if I am handed over with this only 2 function design, I would really have a difficult time to unpack this and make some maintenance over it. So that was all about the object and function-based design. Let's go ahead and discuss and to understand the concept or feature of property. That's exactly what we're going to do next. I will see you then.